All right, we're back. We are COMP397 in the winter 2018 semester, and we're week 1, part 2 of our broadcasts, and we're talking about the demo project setup. All right, so earlier today, I created a project that I was working with. I called it COMP397 W2018 lesson 1. What I'd like you to do now is follow me here, right? I want you to go to your desktop, okay, and make a new folder. We'll call it COMP397 W2018, and it'll be lesson 1B. Lesson 1B. For those people who watched earlier today, it's going to be very similar to what we did, but there's going to be some differences because I'm not a robot, right? So I'm going to do some things different. So you've got your folder, and the great thing about Visual Studio Code, I'm going to bring up Visual Studio Code here. Now, the assumption is you've downloaded and installed Visual Studio Code on your machine. I recommend, like I said earlier, a laptop for this course, okay? I don't recommend doing it with a computer in front of you because there's more work to be done, and you have more control with a laptop as opposed to the computer in front of you. However, if you can't, you don't have access to a laptop or whatever, it's okay. You can still use the computer in front of you. It just means you have to do work at school, and there's quite a bit of work to be done. All right, so I'm going to bring up Visual Studio Code. I'm assuming that you've installed it, and I've given you the link for Visual Studio Code. But for those people who forgot where it is, you can go to VS Code or Visual Studio Code and download it. And there's a download for each of the platforms. So Mac, there's also Windows and Linux, right? Which is cool. So why did I choose Visual Studio Code and not Visual Studio? Visual Studio is too fast, number one. We don't normally use it for web development, typically, unless you're planning and deploying a .NET web project. If you're using it for .NET, it's okay. But Visual Studio Code or something like it, an editor, we use for web development. Now, alternates. Let's say you don't like Visual Studio Code. You could use Atom if you want to. So atom.io, if you go there, you could also use another editor. It's a very good editor, very similar to Visual Studio Code, right? And it's written with the same framework. Visual Studio Code, if I'm not wrong, has been written with Electron, which is a native application written with TypeScript, which is very interesting. So Atom is one. Or maybe you're a brackets person. So brackets is an editor that's been made by Adobe. It's also a free editor. You can download and install, and it's very similar to Visual Studio Code in terms of its support. Now, I like Visual Studio Code more because it supports TypeScript more, and we're going to be using TypeScript throughout the semester. One other thing that I can recommend to you is WebStorm. WebStorm is a professional proprietary software by the people at JetBrains, the same people who make Android Studio and the IDEA framework, right? It also makes a great IDE. Now, notice it's an IDE, not an editor. So it's a development environment called WebStorm. It's a little heavier than Visual Studio Code, but it has great code hinting. And I can't say enough about the editor. I think it's really great. You do have access to getting it. You could buy it, but if you're a student, you have access to it for as long as you're a student. You can download the student access, and you can download the whole pack: WebStorm, PHP Storm, CLine, and a bunch of other apps, and they're all free if you're a student. So that's the options. I'm going to be using Visual Studio Code, and my assumption is you've downloaded it and installed it on your machine. As such, let's kick it off. So I'm starting off with Visual Studio Code. I've got my editor here. And what I'm going to do is I'm going to click on this little button here. This is the solution button or the project button, files button. And I'm going to kind of drag and drop this folder from my desktop into my editor like this. What this does, and this is the thing for editors connect directly with the operating system, okay, typically. So Sublime Text is another good example of an editor that connects with the operating system. So what you see here in our files section, you're going to see very similar stuff on the operating system side inside the folder, almost exactly the same. So what I want to do now is I want to make several folders to start scaffolding out the project so it looks right. Okay, so we're setting up the project for the first time. And over the course of several weeks, I'm going to build on this project. Keep building, keep building, keep building until it's where I need you to be. And I'm going to allow you to use my code. So if I make some code with you here, whatever we do together, you can use as a start-off point for your game. Okay? Of course, that's what this thing is about. Think about this as the lab section. Unfortunately, here's the reality, guys. I have 3 hours to give you 5 hours of instruction. Okay? And I have to fit it in somehow, right? So I'm doing this in a slightly different order than I did before, okay? So I'm talking about Visual Studio Code first, and then I'll talk about I'll put up a little PowerPoint that talks about your pitch, which is going to happen 2 weeks from now. You're going to have another deliverable, a pitch, game pitch. 2 weeks from now, I'm going to talk about that later on in another video. All right, so in Visual Studio Code, I'm going to click this button. This button here is the folder button. So I'm going to make a folder. I'm going to call this new folder content. And I'm going to do that again. I'm going to make another folder. I'm going to make this folder scripts. Uh-oh, what's happened? My scripts folder is inside my content folder. That's not that big of a deal. Just drag it out. And now it's on the root. The root of the folder structure is when everything is aligned like this. Notice on the left-hand side, you see all these little arrows? All the ones on the same level are on the root, okay? Okay, so content, scripts, and one more I would recommend is right-click down here and put new folder, assets. So those are the 3 folders at the high level on the outside. Okay, so assets, content, and scripts. It's a folder. I just have little icons so they look different, but they're all folders. Okay, my icons are set up on Visual Studio Code. All right, next, I want to make a file that we're going to use as our manifest. Because this is a website, really, at the end of the day, we need an index.html file. So I'm going to make that. So I'm going to go to File, click it, and put index.html. Now, I'm not going to do a lot of HTML. So if you haven't done a lot of HTML, it's okay, because we're just going to make a website that's going to contain our game. All right? There's not a lot of HTML. There's the bare minimum of HTML and the bare minimum of CSS. We're not making an HTML CSS game. We're making a JavaScript game, like we said. Okay? So here I'm going to type in the words HTML. I've downloaded and installed some extensions, so I get a shortcut. You may not. If I click on HTML5, I get this. Now I've got a bunch of extensions, and I didn't talk about them, but Visual Studio Code is extensible, which means you can download a bunch of extensions. For example, I have an Angular 1, JS Doc, Angular 2, C++, can I use, CMake, Composer, a debugger for Chrome, Git history, Git lens, a bunch of stuff that I've downloaded before. I'm just rolling down here. And if you're on your own and you want to download these extensions, you just got to put the name of the extension up here and it'll find it for you. For example, if I type in Angular, you're going to do an Angular extension, it'll find all the extensions. If you click install, it'll install that type of extension. One thing I'm doing here is I'm using Emmet. And Emmet is a shortcut to create all my HTML, but it's built into Visual Studio Code. So all this stuff is built in, right? So I want you to create this minimum thing. I'm going to go back to my folder view for a second. And this web page, it needs a doc type. It needs HTML tag that stops here, right? It needs a head tag. And inside the head tag, there's 3 meta tags. I'm just going to open this up. The first one details the character set that we're going to be using for the website, which is UTF-8. The second one is really a compatibility with different viewports. So if I'm using an iOS device or an Android device and I want to look at my page, this line basically says, hey, make the width of my page the same size as my device. Okay. The next one makes it so that it's IE Edge compatible, right? And then I have my title. In my title, I want to change this. I want to change my title from document to create.js demo. I may have named it differently this morning. Underneath the title, I'm going to put in a comment. HTML comments look like this. Less than, exclamation point, dash, dash, a comment, right? That's the beginning of a comment. And I put in, this is my CSS section. And that's the end of the comment, right? And I'm going to put some CSS in there. I'm leaving a space. Now I'm going to go to the body of my index.html. And in my body, I'm going to put in a canvas element. And my shortcut, if I put canvas, pound, and then the name of my ID, canvas, and press tab, it'll create my link, my element. This is using Emmet. It's a shortcut language we can use to create web pages faster. Highly recommend you look at it. If you're unsure what this is, if you've never seen that before, you can always look at Emmet. Emmet is really the essential toolkit for HTML developers, and it's cross-compatible. I'm going to put this in there so you can look at it on your own time if you really want to. We're not going to be doing a lot of HTML coding, though. I'll just drop it onto Slack here. But I'll put it in there for your reading pleasure. Emmet. Really awesome. Most web developers these days use something like Emmet to quickly scaffold out their code as opposed to write it by hand, right? All right, that's Emmet. Back to my code. All right, so, okay, I got my canvas. I want to define a width and a height. I'm going to say my width, right now I'm going to set it to 640. And my height, I'm going to set to 480. Here we go, width and height. And what I want to do here is understand what this is doing. My canvas is actually a container for my game. I'm telling it basically it's got to be 640 by 480. That's what I'm saying, how big it is, right? So this is the element where my game lives, okay? I'm going to skip down a couple lines. I'm going to put in another comment. And this is going to be my JavaScript section. Right. I've got my page scaffolded out, but I don't have any code or CSS to attach to it. To do it a little differently than this morning, let's attach some CSS so we can see the canvas. So again, I'm going to click on this little button here, which gives us our application. Under my content, I'm going to click on content, and I'm going to click on the new file. And in there, I'm going to create a new file called game.css. In my game.css, I'm going to put in a pound sign and canvas. And what this is really doing is saying, hey, find any element that has the canvas ID and then do something. So my CSS is going to say, hey, add a border, 1 pixel black that's dotted to the canvas. So if you find anything, any canvas element that has, or any element that has an ID of canvas, put a border around it. That's what this is saying in CSS. CSS is awesome. Back in the day, CSS didn't do as much as it does now, right? And you can get a lot done with CSS without any code. All right, but back in our index.html, now that we have this CSS file, what we have to do is attach it. And I need to do that here. I'm going to go link. I'm going to press tab. And what I'm going to do here is I'm going to point to it. It's going to be under /content. So notice I'm putting /. This is the format we use. / means look in the same folder or the top level folder in the content folder. And I'm looking for game.css. Notice I cannot drag and drop. This is not Visual Studio. This is Visual Studio Code. I have to type it out. Okay? Visual Studio, I can literally just drag and drop. I can drag and drop from one into my index, and it'll code the line for me. We don't want that. We want you to learn about how to do stuff properly. All right, so this is cool. And this is with no code. So with no code, let's run this thing and see what happens. Okay, so how do I do that? I'm going to minimize. I'm going to go into my folder on my operating system. I'm going to double click and open it. And I see that I have my index.html. If I double click it, it's going to show me the page with the outline. And this is what my 640 by 480 looks like. There's no game. There's just a border right now around my canvas. That's all it is. So this will help us identify where the game is going to live, where the game is going to be displayed. That's all the border's for. Later on, we can make this, we can fancy this up. We can center the canvas using some CSS. We can make the border fancy. We can do all kinds of stuff to support the game that's going to be played inside of it. Okay. All right, so that's the first thing we did. We have no code though, but we have some structure. And you know what? This would be a great place to put it up on GitHub. Okay, for those people who've never done Git or GitHub, forgive me for those people who have, right? I'm just going to review it again, right? So if you've never done GitHub before, you need to set up a GitHub account. And I asked you to do that. So GitHub, you can do by right-click, and we'll go do a new incognito window. You can go to github.com. And in github.com, you can set up a new account. You can sign up for free. Okay? Now, GitHub is a service, a cloud service. That's what it is. But Git is the software, the version control software that we're using locally on my machine. Earlier, I did it on the board, but now I'm sharing it with you, so I'll do it here in a drawing program. Just to get you guys to understand what we have to do. So one of the things we're going to be doing all semester is I'm going to be sharing my files with you on GitHub. But what is Git? What is GitHub? Let's talk about it a little bit. So I'm going to make this thing the same size, 640 by 480, just to illustrate it. Here it is, 640 by 480. And let's suppose, let me make my canvas white for now. So this is my screen, but let's suppose I have GitHub. And let's suppose that GitHub is some kind of data store, that sits on my computer. So I'm going to make a little kind of cylinder here that's going to represent my data store. Okay, so I'm drawing this out as if I would draw it on the board. I got my little data store here, and it's on my computer. And the data store itself can point to several files. And let's say I have a folder on the data store that's local. This is on my computer. This is local. So I've got I got a folder, and the folder has a bunch of files. So let's say this is a file. This is another file. This is another file. This is another file. A bunch of files. Okay, and it's inside my folder. All right. Well, what Git allows us to do, just Git alone, it allows us to create a repository that's local to our machine. And the way you do this is with several commands. But by default, Windows machines don't have Git installed, right? You have to download it and install it for yourself. So there's a bit of setup. Now, the machines in front of you may or may not have it installed. I don't know. But you should install it on your laptop. How to do it properly? I want you to go to git-scm.com. The link is also in Slack. And git-scm, it allows you to download Git for Mac, Windows, and Linux. And what this will do is it'll give you the latest version of Git and set it up properly on your machine. Okay, this is the key. Now, sometimes what happens with Windows machines is you have an environment variable problem where when you put a command on the command prompt, it says unrecognized command. The way to fix that is to go into your environment variables through advanced settings in Windows 10 and add Git to the environment variables. I can't do that today, but next week I'll bring my PC and I'll do the exact same setup on my PC. So you've seen it twice. Okay. This is for the Mac setup, but you can definitely download Git and install it both on Mac and Linux. Now, what you should get after you're done is something that looks like this. On Mac, if I go Git -- version, then I'll get some version of Git. Notice my version of Git is older than the latest version, 2.16.1. Your version on Windows may be different as well. It might be 2.10. something. It's okay. As long as you have 2.10. something and greater, then you're good to go. All right? But what Git allows us to do is do Git commands on the terminal. So if I type in Git and enter, I can see that Git is functioning on my terminal or command prompt. If you get unrecognized command, that means your machine is not set up properly, and you have to modify your environment variables. Now we're going to do that fix next week. All right, so now that I have Git, I want to explain what it is. So what I can do is I can put a series of commands in my terminal like the following, and this is really, really big. I'm just going to make this a little bit smaller. So yeah, this is like 40 points. This is way too big. Let's make it so it's like 15 points. That's better. So my first command for Git is git init. Okay, git init. And what git init does is it initializes the Git repository and creates a hidden .git folder inside of your project folder. Can't see it. It's a hidden folder. Now you can expose it in Windows by going to, I believe, folder options, and you can show hidden files and folders in your Windows, or Windows options, I believe it is now. And then you can see the .git folder. So it creates git init. What it does is it creates a hidden .git folder. That's what it does. I'm going to put that in there. So creates a hidden .git folder. And the .git folder keeps track of all your changes. So that folder exists inside of your files. And anytime you make a change to your project, it notes the change. Why is this important? Because Git is used for 3 reasons. And I didn't talk about this morning. I ran into a bit of a slowdown. I had lots of stuff to do this morning. I did a little differently. And this is the benefit of me broadcasting later on. There's 3 reasons you use Git. Collaboration. I want to share with other people. Backup. I want to back up my files so it's on the cloud, right? And GitHub. And version control, right? Because I want to be able to tell the different versions of my code, right? So those 3 reasons. So git init is the command. Here's the command, right? I'm just going to bold this one so you can see it a little better. Maybe it's, there it is. And I'm going to do this now. So let's do it. So I'm going to go to my command prompt. Oh man, well, where is this thing? This isn't where my files and folders are. I got to do my Git all my Git stuff in the same folder as my files and folders. There's 2 ways to do this. In Visual Studio, if you right click on the bottom here, you can do open in terminal. You should see open in command prompt if you're a PC person. What it will do is it'll make a little terminal window or command prompt down here, right? Now, this is fine, and you can do it here if you want. It's exactly looking inside your folders. So this is the perfect place to do it, right? However, I'm going to do it on a bigger terminal window because it's too small for you to see. So this is the second way to do it. I've got my terminal window. Let me go back there. I got my terminal window. And I've got my folder structure, right? Here's my folder right here on my desktop. So what I can do, Windows and Mac, I can type in CD space and drag and drop my folder onto my terminal window and then press enter. What this will do is it'll change directory to the right folder on your machine. Now, I want to make my Git repository in this folder. I don't want to make it some random folder, and definitely not the root folder of your machine. Otherwise, it will mess up everything in your machine. You don't want to do that. Now, here's the first command, git init. What this is going to do is it's going to create this hidden .git folder. And look, it tells you that. It says initialize empty Git repository in users, Thomas, desktop, the name of my project, /.git. This is where it puts it. Now, if I do an ls on the Mac or a dir in Windows, I don't see it because it's hidden. However, if I do an ls -al on the Mac, I can see that it's there. Here it is, my hidden .git folder. Excuse me. This is where everything is going to go. Okay, clear. So that's the first command. The first command is git init. Okay, back to this. My second command, all right, is going to be git add dot. Okay, what the hell is that? Well, git add is an action, and that's what we're using Git for, right? And dot says add everything. It's like star. It's like me using star, some kind of wildcard, right? So I'm adding everything. So this is add everything in the folder to the Git repository, Git repo. I'm going to make this a little bit, I'm going to scrunch it up a little bit so you can see it better. All right, there we go. As I said, I did this on the board last time, and Eddie was like, Tom, can't see a goddamn thing. I'm like, okay. He was right. And we'll just make it a little bit wider. So a couple of commands here, git init and git add dot. Let's do git add dot. So I'm going to go back to my terminal window and do that. Git add dot. Git add dot adds everything to my, I'm flagging all my files that I currently have as the ones I want to add to my new snapshot. Whenever I do stuff with Git, I create a snapshot, and we call this snapshot a commit, right? The commit, what it does is it looks at all the files and says, hey, these are all the files that I want to commit for this particular snapshot. Right now, what I've done is I've actually staged these files. They're ready to commit, but they haven't been added to the Git repository yet. I've just flagged them. So my next command is git commit. And I'll pass this down here so you can see it better. So this is my next command. I'm going to kind of go in here. I'll say git commit -m. And then I'm going to put in brackets initial commit. There's two things I can put. I'm just going to move all this over so you can see it better on my screen here. It's a great thing of doing this. If I had a whiteboard, you wouldn't be able to see everything. All right, so here's git commit -m. This is the command, initial commit. So commit means snapshot. -m stands for message. Initial commit is the message that I'm putting on the snapshot. I'm attaching a message to the snapshot saying, hey, this is my first commit or my initial commit. And this includes all these files that I just put on the staging area. Okay? That's what this thing means. So I'm going to go here. And I'm just going to go down to here and it says, adds message the snapshot. That's what it is. It's really a snapshot of all the files on in my repo right now, in my current development folder. Okay, let's do this. I'm going to go back to my terminal and type that in. Git commit -m initial commit. Now you can use initial commit or first commit. That's the convention. Okay, it shows me that I've added everything in to my repository. I have my first commit. But guess what? It's trapped on my machine, right? So if you look at the machine itself, you look at the diagram, is there any connection in this diagram to something off of my computer? No. So imagine if I have a cloud, I have some kind of cloud, and I'm going to draw it as just as a circle for now, right? I don't have a cloud shape, unfortunately. Well, maybe I have some other kind of shape I can use. I can maybe use a smart polygon or a star. We'll use a star. So here's the shape, right? So here's my cloud. It's not a black star. Let's make it a white star or a gray star. This is my cloud, and this is GitHub. Okay, so let's assume this is GitHub. Somewhere in the cloud, we have our GitHub repo, right? Now, I need to create this GitHub repo. It doesn't exist. I have to go up to GitHub, make a repo, and the repo will be empty. It's just a container that's going to contain your files. So let's do that now. How do I do that? I got to go to GitHub. I'm going to go up to GitHub. Now, I'm going to share all my GitHub stuff with you on github.com/Centennial College. I've already put the link on Slack. All right, so here's my link, Centennial College. Notice I have this lesson from this morning. That's the completed version. I'll make a new one. I'm going to click New. And what it's going to do is going to add a new empty repository. So I'm going to call this COMP397-Winter 2018 Lesson 1B, just like we did with the other one. I press Enter. It's going to give me this information. Look, it's all the commands we had to type, right? But there's a couple ones that are included here that we didn't include already. And these last two commands, git remote add and git push, what they do is the remote is the connection between your local Git files and GitHub. Origin is the name of the remote. I have a connection. I'm just giving a name to it, origin. You can make whatever name you want. And then what's the URI? The connection string is right here. How am I connecting to GitHub? I'm connecting with here. And it's the same name as my Git repository plus .git at the end. So if I copy this one here, I'm going to add it into my code here. And I'm going to put it in here. This is the message, git remote add. It's a big long line, right? And you can see all I want you to know is git remote add origin and some URL, whatever the URL is. It can be off screen for now. But what this is the connection, right? Oops. Let's keep going. So this is the connection to GitHub. That's what this thing is, right? People get confused. What the heck is origin? Origin is the name of the connection. So what I mean is, let's make a connection. Let's make a line that goes to our repository to GitHub. This is the remote. Okay, so this is the remote, right? And the name is origin. Named origin. You can name it whatever you want. Convention, though, tells us most times we name it to origin. It's just a convention. Okay. Remote named origin. That's what the connection is right here. Okay, cool. That's this line. And there's another line here. I'm not going to type them in yet. Git push -u origin master. Okay. Put that in. What is this? This is upload project or snapshot to GitHub in the master branch. Okay, what the heck is the master branch? What is a branch? Well, with GitHub, I'm just going to make this a little bit tighter here. With GitHub, what you can do is you can establish several branches for your code. What I mean by branches, like you start off coding in a certain fashion, and I create a branch of development, right? And I can add as many branches as I want, to my development. Each branch is a copy of the original repo, right? So why would I do that? So think about this. I have my master branch. Typically, it's the master branch, the main branch, right? And then you and I are coding, and I want to fix a bug. So I make another branch that's based off of my master branch, and all I do is my bug fix inside that branch, right? If it doesn't work, it's okay. I'm not going to affect the master branch. It's a copy. And for other reasons too. For now, know that there's a master branch, a main folder, if you will, that this goes to. Now this means git push upload -u means unconditional to the origin remote, right? Into the master branch. That's what this means. Okay, I'm detailing this slowly for you, so it's recorded. You can always go back and use it again. Okay. Now I could type this stuff, but guess what's really easier to do? I can copy and paste the last 2 lines of code, right? Go back to my terminal window. If you're a PC user, just right-click and press enter. If you're a Mac user, Command V and press enter. And what this is going to do is it's going to push or upload your code to the origin remote into the master branch. Now, if you've done this for the first time, it's going to ask you to log in. It's going to ask you for your Git credentials. It's going to ask you for some stuff. You may have to answer some questions. But if after this, once you set up for the first time, you can do this every time, no problem. So what have I done? Well, if I look up on GitHub now, and if I refresh, then I have my files. Here's my index.html. I can see it. Please join me. Go up on this site. Go to github.com/Centennial College /COMP397 Winter 2017 Lesson 1B. Go look there. You can see my files. And what I'm going to be doing as I work, I'm going to update my repo. So please remind me to push, because if I'm going too fast, Ashley, I give you permission to say, Tom, push, right? And I'll stop what I'm doing and I'll push my changes. This way you can keep track of what I'm doing. Otherwise, I'm going to run as fast as I can towards 6:30. Okay? So I'm going to give you as much as I can. All right, so what have I done? I've pushed to GitHub. Okay, great. What does it look like in Visual Studio Code? Well, once I push to GitHub, take a look at the bottom left-hand corner. Visual Studio Code notices that I've pushed. It says master on the left. It detects that it's the master branch, right? There's a bunch of icons here. One of them is the GitHub icon right here, my source control. And what I can do is it'll show me any changes I make from here on in, right here in this particular point. All right. So I've added in my first commit. I've taken a snapshot of my files and I've put it up on GitHub for the first time. Okay, but we don't have any JavaScript. And this is the time I'm going to add JavaScript first. I'm going to do JavaScript first. How do I do that? I'm going to go into my scripts folder. I'm going to make another folder in my scripts folder called core. Follow me here. This is the structure I want from you. So a folder called core. Scripts, core. Another folder inside of the scripts folder. Inside my core folder, I'm going to put a new file called game.js. Game.js. All right, cool. There's my game.js file. All right, immediately what I want to do is link it to my index.html, because if I don't connect it to my index.html, it'll never run. Remember, my index.html is the manifest that runs my entire game. It links my entire game together, right? So back in my index.html, I'm going to go back into the JavaScript section. I'm going to add in a link. So I'm going to say script. I'm going to put in source equals to /, right? Scripts for game.js. And what this does is this is the path to go to my game.js file. Okay. So I've connected my game.js file, which right now is empty, to my index.html with this line on line number 15. Okay. Just like I did my CSS file on line number 9, where I connected to my index.html, so too am I connecting my script on line 15, right? When my script is connected, I want you to think about it as it's going to explode or expand in that particular line when I run my application. When I go to my website, any script that's attached to my index.html will be injected at this particular location, wherever I put it. So I want you to think about it as actually being scripted right in here, right? As opposed to a separately. It's not separate. It'll inject it in when the interpreter, the web browser interprets my code, it'll inject my script right in here. Back to my script. All right. Did you guys take JavaScript COMP397? You may have taken that maybe with Joanne Filati, maybe with other people as well. Okay. If you did, and if you learned about the DOM and the BOM, you may have learned that stuff. The document object model, the browser object model. You may have learned how to manipulate stuff with JavaScript, how to connect to an element, make a button click and stuff like that. Okay, all that stuff is useless. Sorry to tell you, right? We're not doing that. This is not DOM manipulation. We're not doing BOM manipulation. We're actually making a game. It's going to be sitting inside the canvas element. The only piece of code we're going to use that creates the DOM connection is our link to the canvas element. In that, there's a problem. JavaScript makes the old JavaScript, so ECMAScript 5 and before, when we declare variables. Anyone know anything about JavaScript? How do we declare variables in JavaScript? You guys learned. You went to COMP397. What do you do? var. Yeah, no. We're not going to use var anymore, right? var, it has a problem. And there's a problem called hoisting, all right? What this means is if I have some kind of closure and I declare a variable, my variable, right? And I say my variable is equal to 0, right? As an example. The closure could be an if statement. I'm not putting it here. An if statement, a for loop, or whatever, right? Because I'm using var, what JavaScript does is it hoists this variable to the top of the file. So it escapes my closure. This is bad because it puts it inside of the, it could put it potentially in the global namespace. I don't want that. So instead of using var, we're going to use the keyword let from now on. which is the ECMAScript 2015-2016 standard. Okay. The other one we can use is, another modifier we can use is const. Const is very similar to what it is in C#. Const basically says that this variable can't be changed. It's a constant, it's not a variable anymore. So those are the three different types. So we're going to use const and let. We will not be using var this whole semester as much as possible. If you see var in a code sample online, when you bring it into your code, change it to let, and you'll be okay. On that, because we're dealing with a fixed, an area where we want to protect our variables, we want to create something called an IFI in our JavaScript. Does anyone know what that is? An IFI. It actually stands for an immediately invoked function expression. Have you heard of that? Like I said, dumb, bomb, useless. So what that is, it looks like this. So here's the IFI. It stands for immediately invoked function expression. What this is a closure that you write like this. Not, by the way, I'm not trying to belittle what you guys learned on the JavaScript side. It just doesn't apply to what we're doing. We're making a game. It's not a website necessarily, so it doesn't work the same way. So what is this thing? This is pretty ugly, right? Well, what it does is it calls a function that's anonymous. It's also called an anonymous self-executing function. That's what it is. It's an anonymous function that gets called as soon as it gets seen. Okay. Anonymous self-executing function. Okay, and what this is saying, hey, anything in between these curly braces is inside of a closure. So it's not going to escape into the general namespace, the global namespace. It will not escape. It'll be inside this function namespace. Okay, this is important because we can control the scope of our variables, right? As opposed to, imagine if I didn't have this, and if I had a score for my game, I can go in there and type score is equal to 1,000,000, and then I have 1,000,000 score. You can do that in the browser actually. You can go in there as long as the variable exists in the cache of the browser, which it would if it was in global namespace. I can type it in, and I'll show you that later on. But here it won't work. You won't be able to type that variable because it's enclosed, it's encapsulated in this closure called an IFI, an immediately invoked function expression. Here we're going to decide, we're going to create some structure for our code. Just like Eddie said earlier, we're going to make it so that it's very Unity-like. In this first file, we're going to use a couple of functions. So we'll make some name functions. Function, the name of the function is going to be init. We're going to make another function with the name of start. That's very Unity-like. We're going to make another function with the name of update. Notice I'm using capitals for these functions. That's just my convention. And the last function I'm going to make is going to be called main. What are these things? Why am I making all these functions? I'm structuring my code so it doesn't look like spaghetti code. One of the challenges that we have in JavaScript is it looks like spaghetti. We don't know what the hell's going on. We look at it and we're like, wow, it's completely unorganized. I have no idea what's happening. We don't want that to happen in our files. So we're creating a series of functions that are going to give us some functionality. I want you to think of it like this. Each function should have one main reason for living, one reason for doing something, right? At the end of our main function here, I want to create a little piece of code, which is an event listener. I'm going to look at the window object. This is the first time we're using the DOM, all right, or the BOM. I'm going to say window.onload, right? And I'm going to say when the window loads, call the init function. Wait a minute. How come? Here's the init function up here. How come I don't have to put brackets like this? What's actually happening here is it's saying here, I've got an event handler, or event listener. When the window loads, listen for the window loading event. Okay, cool. The window loaded. Now, make a reference to the function that I'm going to call when the window loads. That's what the equals init is. I'm making a reference, and I'm storing it inside of my onload function, right? So when the window loads, it's just going to call the init function immediately. This is good because I'm going to wait for the window to load, and then I'm going to draw my stuff. And the problem is, if I didn't wait for my window to load, I could try and make my game, but it would never show up because my game is trying to put something in play when the window hasn't loaded yet. So then I would never see it. All right, so that's why I have to wait for my window to load. So I've got a bunch of functions here. And you know what? In my init function, I'm going to say console.log. This is like going to give a small message. Equivalent in C#, it's console.writeLine. And in Java, it's system.out.println. And in C++, it's standard : cout, right? What this is going to do is output to the console. And I'm going to say something like initialization started. This is where I initialize my variables. I'm going to use the init function to initialize variables, preload stuff, that kind of thing. That's what my initialization is going to work. So here's the effect that I want. When I look at my web page now and I look at the console, it should show initialization started. If it does, great. I've done everything. It's my JavaScript file is linked and it's running. I'm going to save it. And let's see if I can go over to my index.html over here. That's not what I want. And run it. So if I refresh and I right click and I go inspect, and if I go to my console, you can see that it says initialization started. This is good. It's a good sign. Also, I want you to think about this. I'm using Chrome. I'm not going to be using IE or Edge in this course. And I'm not going to use Firefox. So if you want to be like me, use Chrome, right? I'm not saying that Firefox or the other browsers are no good. Opera has become better these days as well. I'm just using Chrome because it's kind of standard. One thing to note is in Chrome, you can also look at sources. So if I click on the sources button, then it tells me, it gives me a look of what my folder structure looks like. And I can see my folder. Here's my game.js. I can actually see my files right here inside my folder structure, right in the browser. Very, very useful. And we're going to be doing some debugging in the browser later on in this course, right? So our browser then gives us the view to our game. We do all the logic inside of the JavaScript files. The presentation, how the outside of the game, we do with CSS. But we're not going to do much with CSS. Okay, great. So we've done this piece, and it's nice, right? But wait a minute. What about variables? We talked about variables as you can use let and const. But what types of variable are there types in JavaScript? Are there variables in JavaScript?
I didn't know about that.
There is. There's data types in JavaScript. Technically, yes. All right. Okay, so what are they? There's a number, string, Boolean, object, right? And any, and a bunch of other ones. And what these variables are, how do I declare a variable? I don't say, well, variable, my variable. I can't do this. I can't say variable, my variable. By the way, I'm not going to use variable. Is of type, I'm not going to do how we do it in C# where I say it's a string, right? My variable. We can't do that. In JavaScript, we use something called type inference. So we might say something like, let my variable equal to, foo. And now what type is my variable? String. And if I hover over it, it'll tell you that, right? By the way, this hovering over stuff, that's Visual Studio Code. It gives you insight into what the type is of an object when you assign it. Okay, so let my variables equal foo is a string, but guess what I can do right after? I can do one of these. I can say let my variable, right, is equal to 1. Now my variable is a number. And this, my friends, is the biggest confusion and hatred towards JavaScript that developers have. They look at it and they're like, wait a minute, it's completely unstructured. Why the heck would I want to use JavaScript? It's loosely typed. I can change anything I want. And so we go to the reason why we're using TypeScript. TypeScript gives us tooling. TypeScript makes JavaScript easier. TypeScript allows us to use the classical inheritance that we're used to from other languages like C# and Java. Here, making inheritance with JavaScript, I need to use prototypal inheritance. I need to do a function within a function within a function, or so-called callback hell sometimes, right? I don't have to do that with TypeScript. Now, we ran into a problem earlier. We need to install a couple things to get TypeScript support, okay? One, I need you to install Node.js. So let's go get that. So I'm going to go over here. I'm going to go to nodejs.org. Here it is. I'm going to put this link in Slack, nodejs.org. And what nodejs.org does, right, is it allows us to download Node for our machines. Okay. Now, if you're a Mac person, I don't recommend you downloading it this way. If you're a Mac person, you want to use Homebrew. So I'm going to, I actually put that link, if I'm not wrong, in Slack. If I go up here, I think I put that link. Yeah, I did that here, right here. In fact, I can just erase this one because I already had that message up here. So right here, if you notice in Slack, I have Node.js for Mac, and there's Node.js for Windows if you just download and install this latest version, 9.40. Now, same problem that you may have encountered in GitHub or Git, you may encounter here. You might get an unrecognized command if you don't install it properly, right, in your terminal. I recommend you close down your terminal when you're installing Node.js because it may not detect the changes to your path, okay? Why am I using Node.js? I'm not building a server-side anything. I need Node.js to get stuff from the web. We're going to use the Node package manager called npm. Here's npm. To get stuff from the web. Remember I talked about this earlier? And some people said, oh my God, I think it was you. You said, there's so much to learn. There's so much to learn. Because you got to use Visual Studio. You got to download and install Git. You got to download and install Node. You got to download and install npm, right? What's happening with Node. Now we're going to install TypeScript. We're going to download and install Yarn next week. We're going to keep doing it. And we're going to do it until the point where we have everything we need. We're not going to get everything we need until probably next week. So this what makes web development hard. Lots of tools, lots of changes. Every 3 months, something changes on the web. My version changes. It breaks sometimes the previous versions. Games are hard. Game making is hard. It's the hardest thing you'll do. Harder than any application development. Harder than making a banking application, right? All right, so we've got npm. And how does this work? How does npm work? Well, npm, if I look at TypeScript, we want to install TypeScript. So if you go to typescriptlang.org, and if you go to the documentation, right, you can see that under tutorials, right, TypeScript in 5 minutes, that there's this line, npm install -g TypeScript, right? And what this does, npm is, it'll install TypeScript. But what we have to do is we have to set up a couple of files in our folder structure to support TypeScript first. So let's do that first in our folder before we do this. So going back to our folder structure, I'm going to put in a couple of files to support TypeScript. One of them is going to be a new file called tsconfig.json. What is this file? It tells TypeScript how to transpile from TypeScript to pure JavaScript, so that it makes it 100% compatible across all websites, right? And in here, what we can do is we can put curly braces, and control space will give us some compiler options. And inside the compiler options, we want to indicate what module type we want to use. We want to use common.js for now. Next week, we might use something else. And our target is going to be ES5, ECMAScript 5. So we're targeting an earlier version. Oops, I made a mistake here. An earlier version of JavaScript so that it's compatible. One more thing I want is source maps. Source maps give us code hinting when it comes to where the problem is from a debugging perspective inside of our code for both JavaScript and TypeScript. So source maps are really cool for debugging, all right? So this is what I want you to set up in your tsconfig.json. So that's the first thing. This is before we even set up TypeScript. Next, I need to install a .gitignore file. Okay, I know it's a lot of installations. Let's do this. So new .gitignore file. My .gitignore file is a special file that goes along with Git, and it tells GitHub and Git not to push certain files and folders. One of the ones I never want to push to GitHub is node modules. That's the folder I don't want to push. Now, I don't have that folder yet, but I'm going to get it when I use npm. When I use npm to install TypeScript, it's going to create a node modules folder. And this node modules folder can be quite large. It can have thousands of files inside of it because it's a package that I'm getting from the internet. It's not my code, it's somebody else's, right? But this is helper code that's going to make my life easier later. So I want you to install this .gitignore file. Next, in the command prompt for your files, I'm going to clear the screen. On Mac, it's clear. On PC, it's CLS. I want to do an npm init. Now, if you've installed npm properly, you should be able to do npm -v, and it should give you a version like 5.6. If you can't do that and you get unrecognized command, something's wrong with your installation again. All right, but if you can get npm -v and you get some kind of version, that's good. Now you can do npm install TypeScript -g for global. So what this will do is it'll install TypeScript, the language, globally in your system. So you can use it for any project. All right. If I press enter, it's going to go out, grab TypeScript, and include it in my folder structure for my entire computer. My computer will have it. -g is for global. All right. Next. Because I'm going to be adding other npm modules inside my project, I want to do an npm init. npm init creates a project.json folder, right? Or a package.json folder, sorry. And the package.json folder is going to keep track of all my dependencies for my project. Now, typically, you don't need that. In other code, like when you do C# or Java, you don't have to do this stuff. It's all done for you by Visual Studio. But we're doing it by hand because we're using an editor. So I'm going to press npm init. It's going to ask me for the name of my project, and I'm just going to accept all the defaults. I'm going to press enter, 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 enter. Keep pressing enter the whole way. What this does is it creates a package.json file inside my folder. And the package.json file keeps track of your GitHub from a repository perspective, the author, that's me, your home page, you can change this if you want later on, and a bunch of other things. But it also keeps track of your dependencies. We're going to use this later. For now, just know we need these files. So I've added 3 files now. A .gitignore with node modules, a tsconfig.json, which I created my configuration. That's weird, that gives me an error. Did I make a mistake somewhere? I didn't. A package.json file, which basically gives me a, for any npm that I want to install, any module I want to install, is going to be listed here as a dependency. Okay, great. This is a great place to push it up on GitHub because I'm kind of creating support for node modules. So notice I'm clicking on, now I'm going to do it the other way around. I'm clicking in my Git or source control link, and I'm going to kind of put in a little comment that says added npm support. I'm also going to add all these files to the staging area. I'm going to go back up where it says changes here and click the plus button. And it's going to stage all of these files that I'm going to add into my GitHub. So I can do it 2 ways. I can do it strictly through command line, and I can do it through here, the built-in tool that is that's inside of Visual Studio Code. And then I'm going to click on this checkbox. And what the checkbox will do is create that commit, the snapshot. I just made a snapshot, but I did it in Visual Studio Code, not on command line. And then these ellipses on the right here, I'm going to click the ellipses, and I'm going to click push. And this is going to push my changes to GitHub. So now, if you were too slow, you can go on GitHub and see what I did. If I go to GitHub, I can take a look at that file. And if I refresh, I should now have 2 commits with all these files. And you can look at them up online. Here's my tsconfig.json file, and so on. So we're preparing for TypeScript. I haven't gotten there yet. I'm preparing. I've loaded TypeScript in, and now I want to use TypeScript. In order for me to use TypeScript, I got to rename my core game.js. I want to rename it to game.ts. Let's rename it. So rename. I'm going to change it from game.js to game.ts. Now, notice there's a couple of things I want you to note. One, immediately TypeScript determines there's a problem. Take a look at my tooling here. It says, wait, the variable's been declared twice. It didn't do that in JavaScript. JavaScript allowed it. TypeScript says, whoa, there's a problem. Potentially there's a problem here, which is right. We shouldn't be able to redeclare a variable. So let's get rid of that. The other thing that TypeScript allows us to do is declare the type immediately. I can say that my variable is of type string. So the colon tells TypeScript that's the type. And it follows the variable, the identifier, whatever the identifier is for the variable. So if I called my variable, and I put a colon and string is the type. I explicitly tell it what type it is now, as opposed to have it infer the type. I don't want to have it infer the type. Why is this good? Because if I say it's a string and then I attach a number to it, like this, it'll give me an error again. Code hinting. It'll be good tooling. It'll say, wait, type 1 is not assignable to a type of string. There's a problem. Now, in real life, when it transpiles, it doesn't care. It'll make it whatever you want. JavaScript will work. But TypeScript says, wait, this is not what you intended. You said it was supposed to be a string, but you're assigning a number, right? All right. So this is one of the things that TypeScript does for us. I can say, foo. But the problem is that browsers don't understand a game.ts file. There is no TS the browsers understand. We have to transpile. We have to convert from TypeScript to JavaScript. And the way to do that in Visual Studio Code is Control-Shift-B. Control-Shift-B. If you've got TypeScript working and you've got the tsconfig.json file, you can press Control-Shift-B, or on the Mac, Command-Shift-B, and it'll pull up this little task manager up here. And the task manager has 2 options. One, build, and the other one, watch. We want the watch task. Control-Shift-B. B, as in Bob. Build, Control-Shift-B. Actually, it's the same command for Visual Studio. Okay, what the hell did I just do? Guess what it did? It converted it. Here's my TS file. It made a JS map, and it made a .js file. Here's what my JS file looks like. It's almost identical to my TS file, except it's a little bit more compressed. All the spaces have been taken out between the function calls. But wait a minute, you're going to say, that's a lot of work that I just did to get a little bit of thing. That's no good, Tom. I don't want to use TypeScript. I want to use JavaScript. If that's all it does, forget it. That's not all it does. Let's go to TypeScript Playgrounds for a second. So if I go to TypeScript Playgrounds, and what I want to do, if you look at TypeScript, the website, if you click on Playground, so typescriptlang.org, you go to Playground. And what I want to do here is I want to create a new class. Now in C# or in Java, you can simply do this, class. Take a look what it's doing on the right. As soon as I type class, it's starting to create an iffy. It's starting to create a closure. All right, and it's got a function within a function automatically when I just type the word class. That's what that's what TypeScript is doing, right? All right, and then when I type class, I want to name the class. So for example, I'm making a game object, and the game object needs a position, rotation, and scale. So maybe that's the transform, but I want a location. So I say class, right? Is my location class, right? Don't worry about the underscore here. It's wrong. It doesn't actually mean anything. It says duplicate identifier location. There isn't a duplicate identifier location here. There is not at all. See? I mean, so what I'm doing here is I'm saying class location, and the location is going to have X and Y, right? So I'm going to make them public. X is equal to a number, and public Y is equal to a number. Is this understandable to you, what I'm doing here? Okay, look on the right. Do you see X and Y here in my location class? Hell no, not yet. All right, let's keep going. And then in my class, well, I want to make a transform like we do in Unity, right? So class transform, and transform is going to have a location, right? So I'm going to say, you know, location, public, location, right? Which is of type location is equal to a new location. And I can even go so far as to say something like this. In my location, I can create a constructor function, right? In my constructor, I can put in a couple things. I can initialize my X and Y coordinates to 0. So I can say, well, X is a number. I want to assign it to 0 by default. Y is a number. I want to assign it to 0 by default, right? Here it is. Now X and Y is something that I can attach to my transform. You can see what's happening here on the right. That's the JavaScript. This is the TypeScript, right? You tell me what's easier. I'll make another class, which is game object. And I want to make it inherit from, you know, actually, I won't extend. I want it to compose a new transform components. So I'll say public transform, which is of type transform, is equal to a new transform. I could do this different ways, by the way. I'm just doing it quickly. And now I have my player, which extends the game object class. My player has a move function, right, that takes an X and Y location, right? And what it does is it changes the transform right? And I can make it that this returns, this public function here returns void, right? Now you can see all the stuff that's been added into the JavaScript side. The JavaScript side is not understandable. It becomes a function within a function. It adds ifs all over the place to separate the functions, the classes. Whereas we're really used to this. It makes sense, right? Let's actually add, we'll make it location lowercase, see if that works. About position. Yeah, that worked. Sorry, I want to take away the error. Because position is taken. Position is actually something that's in the HTML browser, right? And I'm going to try and tell what it is. So class position, blah, blah, blah. And furthermore, what you can do is you can put it inside of a module. So I can put this in a separate file. So I can call this module, you know, utility. And I can take this whole class, all these classes, and encapsulate them inside of a module. You can see what it does. So you judge. Left side, right side. Left side to me is way easier. Left side makes sense. Right side is spaghetti, right? Now I understand how to do both ways. I can do it with pure vanilla JavaScript. That's what they call the right side, right? Well, why? And there's no time in this course. We have no time to do vanilla JavaScript in this course, okay? And that's why we're not doing it. So this is cool, but I want to add in create.js. I want to add create.js. Create.js is what we're really doing. We're doing this TypeScript so I can add in create.js. And create.js is a library that we're going to use to create our game with, right? Now, there's 3 libraries or 4 libraries that create.js has. If I go to createjs.com, there's 4 libraries that this thing comes with. It comes with EaselJS, which controls the canvas. Tween.js, which handles some kind of transitions and lerping. Does really nice animations, tweening. Sound.js, which actually activates sounds in our browser, right? Preload.js, which allows us to preload images and files so that it doesn't take a lot longer. We don't do a lot of, file calls or OS calls. So we preload all of our files to make it more efficient to load, okay? So there's several different, a suite of library, and we want to use EaselJS for today. Now, I could install EaselJS with you, and I'm going to do it next week with Yarn, another tool. I'm not going to do that this week. We've got enough tools, right? So I'm going to use a CDN instead. A CDN stands for the Content Delivery Network. And what it is they already host the JavaScript libraries online somewhere. So we're going to just use that one for today. Okay? So if I click download, if I go to EaselJS and click download, there's 3 ways you can do it. I can use the CDN, or I can copy the CDN URL, or I can go to GitHub, right? So if I click on CDN, it's going to take me down here. And if I scroll down, you can see that I have the script for the CDN right here. And this is what I have to install in my browser. So I'm going to take this script, copy it. I'm going to go back to my index.html file, right? And I want to put it, remember what happens with JavaScript files. They go in the order that you put them in. I want to have access to the EaselJS framework before I do my game.js. So I'm going to put it above it here. I'm just going to copy paste. So this is going to a website to get the code, right? And what this does is it uses the Content Delivery Network, the latest version that they've uploaded to the Content Delivery Network. And many times this is faster than running it locally. The reason why is because people, if you've used EaselJS before, it's been cached in your browser already, right? So they don't have to reload the browser. It actually loads faster for the user. We're not going to do this. Next week, we're actually going to download everything by hand, and I'll get you to recreate the EaselJS, Tween.js, Preload.js, all those things inside of your folder structure. For today, though, all I want to do is just make a demo and use create.js. So I'm going to use a CDN here. So I'm just going to say use the EaselJS CDN link. That's what I've done here. Okay. Okay, cool. We have it, but I want to use it, and we still have a problem. But this is where TypeScript can help us out. So if I go in here and type create.js, if I just start typing create.js, I get nothing. I don't get any code hinting for my new library. Wow, what a pain in the ass. That means I need to know the API calls by hand. That's crap. What if there was a way to get code hinting for any library that's on the web? TypeScript is the answer. TypeScript can include something called TypeScript definition files, right? And they have it for most libraries on the web. For example, it has one for jQuery. All the big libraries that exist on the web, there's TypeScript support for them. And TypeScript's being used by Angular, which is made by Google and supported by Microsoft. So it's not going to go away anytime soon. All right, so I want to get support. Notice that there's nothing that says here create.js. How do I get support? I need to use npm. Remember I did npm? Let's go back to my terminal again. So here's my terminal. I'm going to clear the screen. And I'm going to download and install a small npm module, which is my EaselJS type. I'm going to say npm install @types /EaselJS. And then --save -dev. What --save -dev is, it says, hey, this is not a project dependency. It's a development dependency because I don't need this thing to run my project. I just need to get good code hinting. So it's not a dependency. A dependency is where I depend on it for my project to run. All right. I press enter. It's going to go out to the web, grab the module that I want, and install it inside of my Node modules folder. Notice how my Node modules folder now appears. And inside there, we have a couple of files. All right. We don't ever want to put these files up on GitHub because there'll be thousands of files eventually. So that's why we've excluded them by putting this .gitignore file in Node modules. Okay, cool. So we've got that. Well, let's see if we get code hinting now. So if I type create.js, there it is, right? And this is good. This is what we want. We want my Visual Studio Code or my editor to help me write my code. I don't want to look on the API every single time, and I want it to help me so I don't make mistakes, right? Because more mistakes are made by doing it the wrong way. Okay, let's make the example happen. And then we'll do the PowerPoint, and then we'll go home. So in order for me to kick off the create.js project, I need to do a couple things. First, I'm just going to pass through my init function. Okay, so I'm going to call from my init function. I'm going to call my start function for now. In my start method, I'm going to make another console log command. By the way, in the morning I did it slightly different, or at 12:30, and I'll call this starting application. Right, initialization started, starting application. Inside my start method is where everything's going to happen. Ready? I need a couple of global variables. So these global variables are going to be what we call game variables. Game variables. One of them is the canvas element. Let canvas equal to, now this is the first time and only time we're going to use document call, document.getElementById, and we're going to target the canvas, a canvas with a canvas element. So what this does is says, hey, my canvas, by the way, if you notice, if I hover over, it says it's of type HTML element. It detects what type it is. There's other types, right? Okay, cool. And I also want to create a new variable called stage. Stage is of type create.js.stage. And notice I can create a type without assigning a value. That's just like me doing var stage. Simple, it's the same thing in JavaScript. All right, so I got my canvas and I got my stage. I'm going to use my stage down here. And this is how create.js is initialized. All right, I need to create my stage. So I'm going to say stage is equal to a new create.js.stage object, which I'm going to pass in a reference to my canvas. But what is a stage? You know that a canvas is an element, HTML element, right? My stage is an object. It's a container that holds all the display elements for my game, right? So my stage, think about it as a scene, right? I have everything inside of there. My stage contains, it's an array that contains all of my display elements. That's what it is. Right now, there's no display elements. It's just empty. I want you to think of something else. My canvas is also something that I'm refreshing at a certain frame rate. When we talk about frame rate, if you're not a game person, frame rate means how often every second I refresh or redraw the stuff that's inside my canvas element. How many times per second? Typically, games run at 60 frames per second, right? That means every 16.666 milliseconds, my canvas element is redrawn every 16.66 milliseconds, right? Typically, TV and movies run at 24 frames per second. Our persistence of vision, humans can only see about 24 frames per second. Beyond that, it's the same. We use the extra frames for more calculations, right? Every frame we calculate, we do computations for our game, right? So the faster the game runs, the better. Typically, we can sustain for the web around 60 frames per second right now. In the future, maybe it'll be 90. Maybe it'll be 120, like some console games. So the way we set that up was we say create.js ticker, an object that belongs to create.js, dot frame rate is equal to 60. Oops. I don't know what I did there. I shot down to here for some reason, is equal to 60, which is equal to 60 FPS, 60 frames per second, right? So we set up the frame rate. We say how many times the stage is going to be updated or redrawn. Next, I'm going to create an event. I'm going to say every time I have a new frame, so every tick, a tick is considered a frame. Every time I have a frame, I want to call the update function. My update function is right here, right? So this update function will be called every frame, 60 times per second. Yeah. Yeah. It might. It'll try to produce it every frame, 60 frames a second. It'll try. For example, if you use a older laptop and go to a website and it's trying to serve you 60 frames per second, it may not work, right? You might get 50 frames per second. You might get 40 frames per second. But you're trying to get 60 frames per second. It's trying to update the stage 60 times a second. That's what it's trying to do. Yes, in a single thread. Yeah. All right, so now after we update it, we call the main function. All right, in my update, what I want to do is I want to say stage.update. And let's make it more TypeScript compatible. Stage.update redraws stage. That's what this does. Now, because it's TypeScript, I can do things like this. This function returns void. Doesn't return anything, right? This function returns void. Doesn't return anything. This function returns void. And so does this function. The return type we can modify when we need to return something, right? And we can check it. Again, good tooling. That's what TypeScript is for. The majority of what we use TypeScript is for tooling to get good, kind of responses from the system. All right, good. So we've done this, 60 frames per second. We've called main. Now we'll say console.log game started. So here, starting application, here the game is actually started when it gets to this point. So you can track where the application is going every time, right? All right, well, let's run this thing and see what happens. So I save it. When I save it, because I'm watching, it'll automatically transpile, right? From TypeScript to JavaScript. This is the JavaScript translation of what it is wrote. Notice it's exactly the same because at its very core, TypeScript is JavaScript. It's just the latest version of JavaScript. And one day we won't need TypeScript because our browsers will support the new features that JavaScript is coming out with. All right, so we got this going on. Let's see what it looks like in the browser. So I'm going to go back to here. I'm going to go to my desktop. I'm going to go to my site there. I don't know why I did it this way, but that's fine. Here it is. And if I double click on my index.html, thank you, then I should get this. I got nothing, right? But if I open it up and if I go to inspect, I should see all the different events that I saw. So I initially started, it went to my init function, it went to my start function, it went to my main function. That's what happened. We know it worked. And you can see that it tells you where in the TS file it was triggered, right? These are all the places where it's working. Not yet. No, it's updating. It's updating, but you can't see it. Nothing's happening, right? Let's add a hello world, okay? A hello world. How do I do that? Well, I need something else. So I created I'm going to go to my TS. I created a stage and a canvas. Let's make a hello label in the global space for now. Hello label. And we're going to make it of type createjs.text. So we're just declaring the type. It's a text type. Create.js and EaselJS has a bunch of different classes built in. We'll talk about them as we go. So text is a text file or a text object. I'm going to go back down to main, and inside main, I'm going to attach my text object to my stage. How do I do that? First of all, I have to create the object. So I'm going to say hello label dot is equal to, sorry, new create.js, sorry, dot text. And inside there, it needs a text. Look, it gives me code hinting now. It tells me what I need. I need a text object. So hello world, right? It needs a font. So we'll say 40 pixels consoles. It needs a color. So we'll say pound 000000 black, right? And that's my object. But I haven't added it to the stage. It's just an object I've created. I need to add it to the stage, to the display, right? And the way to do that is to say a couple things. One, well, let's change the location. My hello label.x, the x coordinate, is going to be equal to, let's say, 100. And my hello label.y is going to also be equal to 100. Then I'm going to add it to the stage. And the way to do that is I can say stage hello label. So what I've done is I've actually attached my label to the stage. That's what I'm doing here. Okay. And if I save and go back here and refresh, you can see that I got hello world. Now, this is not text I can highlight and copy. These are pixels. I've taken my glyphs that are the font and I've converted them to pixels. That's what Create.js did. I can't highlight this word. I can't copy paste. I can't do that. It's not text object. It's pixels, right? I want my object to spin around. It's easy. Every update, I can do something. In my update function, it gets called every frame. If I want this thing to spin, right, or something on every frame, I put it here in my update. Now, there's other ways to do this. But I could put something like hello label dot rotation plus equals to 5. And what this is going to do is there's X and Y, but it's going to rotate around the Z, which means it's going to rotate around itself, around its center. There is no Z coordinate in 2D, right? Z is into the screen or out of the screen. So we're just going to rotate around its focal point. Now, the default registration point for any object in Create.js is the top left corner, right? So it's going to rotate around the top left corner of the text object. Let's see how this works. Here it is, refresh. Now you can see it's rotating. It's rotating out of frame, out of the screen, but it doesn't matter. And it's doing it 60 frames per second. If I want to rotate the other way around, pretty simple. I just make this a minus. So you can see I have total control over what's inside the canvas. And this is where we're going to make our game, inside the canvas element. Okay, I'm going to put this up on GitHub. So I'm going to go to my GitHub. I'm going to package this all up. I'm going to say that I added TypeScript and Create.js support. I'm going to click on the checkbox. I'm going to go to the ellipses and push. And now you should have everything on my GitHub. Everything I just did now is on GitHub. And if you go home and go through the video again at some point, you should try and make it all work if you couldn't make it work today. All right? Because that means there's some stuff that's missing. Next week, I'll do some more corrections. I'll bring my PC in. And for people who are using our PC, I'll make it so it works on the PC as opposed to the Mac. Okay. So we did this. Our demo's done. We know what, I kind of give you a sense of why we're using TypeScript, you know, as opposed to JavaScript. It makes JavaScript easier. But I wanted to run through a very short PowerPoint presentation that I put up actually online for you. And then I'm going to go 2 weeks from now, just to recap. Next week, you're putting in your contract for your team. That's due next week, Saturday at midnight, right? But I'm also in the schedule 2 weeks from now, you're going to do a game pitch. And I want to talk about game pitches a little bit. So I did this a little bit differently, and I could create a separate slide for this. This is 13 slides. I'm going to run through this fairly quickly. So what is your game? You're making a game each game has something called like a DNA. We called it an MDA, right? Mechanics, dynamics, and aesthetics. So for the designers out there, think about what the mechanics are of the game, the rules of the game. When you do your game pitch 2 weeks from now, I want you to talk about this, mechanics. What about the dynamics? How players use the rules? And your aesthetics, the user experience. That's the stuff I want you to talk about a couple weeks from now. Here's an example of Pac-Man. The mechanics are moving, collecting pellets, eating ghosts. The dynamics are maneuvering around ghosts and finding safe paths. And the aesthetics are challenge, power, and anticipation. You can also see that it's a retro dynamic or aesthetic because it looks like a retro game with a top-down camera. Okay? So these are the things that you're going to talk about for your game. Here's another example of Street Fighter. Mechanics, move, crouch, jump, punch, kick, block, grab. Dynamics, you can strategize around how to do it right. Which moves you can combine to make to beat the other guy, right? And aesthetics, there's the challenge, there's the competition, that air of competition. And you also have this background, like they're on a dock somewhere. It looks like these guys are, fighting in front of a boat. So a couple of things for each of your games, right? I want you to talk about that. The other thing is elevator pitches. An elevator pitch is, give me the 30 seconds about what your game is about. So imagine that you're going to say something like, my game is a retro shooter that feels like you're playing, like you're a shooter like, a Mario shooter, let's say. You have Mario, you do platforming, and you're shooting. Some kind of really weird shooter. They actually have games like that. Or my game is like Paper Mario. It's kind of like a 2D aesthetic, right? So it looks like it's a 2D cartoon. And Paper Mario can, slip through blocks and blah, blah. You can talk about what it's like. My game is like so-and-so, right? Should only be 20 to 30 seconds, and you should be very succinct and memorable and talk about what makes your game unique. So think about the tagline or the one-liner. They use it in the movies all the time, right? In a world where there's destruction, a hero rises to defeat the enemy, right? Tagline. What is your tagline for your game, right? I know in a world, they did that, and the guy died, unfortunately. The guy who was doing all that in all those trailers, in a world of, he died lately. So they got other guys to do the same thing now. But they do that, right? They do this tagline. And I want you to think about what your tagline is for your game, right? So is it, does your game have player versus game elements, player versus player elements? Are you doing capture and destroy? Are you doing territory, control? What are you doing in your game, right? Are you jumping? Is it a memory game? Are you building? Is there stealth involved? Here's an example. Pokemon Snap, right? A rail shooter where players must snap pictures of the Pokemon they pass to be graded for quality at the end of each level. A one-liner, right? Or how about Mega Man, right? A first-person shooter heavily weighted on exploration and item collection, following a bounty hunter who must track down an alien threat on a mysterious planet. You can almost say it with that, in a world where the bounty hunter, it's almost the same thing, right? Last slide, and then you guys can go. So think about the stuff we talked about today. I showed you your tooling as a summary overview, right? Lots of tools to learn, right? You learn a little bit of TypeScript. You saw a little bit of Create.js. You saw the Visual Studio Code we're using. Eddie talked about a bunch of stuff in projects, right? Earlier when he did his little demo, right? And here's my advice to you for this semester. One is feature creep. Don't add new features just because they seem cool. Hey, that's really cool. Let's add it in. No, stick to your original plan. Okay. Remember, at most, you're creating a prototype. You're not going to make a game to sell. So don't think about this is going to last till next semester. There is no semester, that next semester. It's only this semester you're going to make your game. That means you got to focus on making the game work this semester. Think about your minimum viable product, stuff that works for your alpha. Don't try and add in extra stuff. Do the exact thing that you need for each of your releases. Division of labor. Make sure that everybody is engaged. Okay, so if there's a member that's not doing something, give them something to do. And the best thing for you to do is plan what everyone's going to do week over week, which is what I've asked you to do when you create your pitch. If you look at the pitch requirements, it tells you, make a chart in your PowerPoint presentation. What is everyone going to do every week? What are they doing, right? And the last point, and I want to leave you with this one, is don't build an engine, build a game. Why? Because you can go crazy, JS, and you're going to build a game engine like Unity. No, don't do that. You're building a game. You're not making perfect code. There is no perfect code today, right? You're going to make just enough code to make things work. If you have to hack it, you're going to hack it, but you're going to make your game work. Okay? Questions around today? I know we covered a lot of stuff, right? By the way, the pace that I've just talked about is going to be the same pace every time. There's going to be a lot of information, and that's why I record everything for you guys. So you can always look back and you know, kind of remember what we talked about. You need to get your hands dirty, okay? So don't just watch. If you couldn't do it with me because I'm too fast, go home and do it yourself, right? Try it out. Make sure you understand what I did, because when it comes to the test, midterm, which is where 15% of your grade, you need to know what you're doing. Any questions? All right, that's it. We'll see you next week.